Today we're talking about section 5.5. This is video part 2. We're just going to continue more examples of solving trig equations. Let's go ahead and look right now at our first example here. You can see that this example contains both sines and tangents, and also there's a sine squared. Now, a general rule of thumb when you're solving a quadratic equation, even if it's a trig equation or not, is to get the equation equal to 0 to start. So let's go ahead and do that. Let's take away 3 tan x's from both sides. When I do that on the left, I'm going to have tan x times sine squared x minus 3 tan x equals 0. I see a common factor here of tan x in both pieces, so I'm going to pull that out in front. When I do that inside, I'm left with sine squared x minus 3. And now I have two things being multiplied equal to 0, so I can split them up using the 0 product property. We're going to solve these two equations separately. The first thing I need to do is look for where tan x equals 0. That's going to happen at 0 and pi. It also happens again at 2 pi, but if you look at where we want our solutions to be, we're not looking for our answers to be equal to 2 pi, we're looking for them to be less than 2 pi. So we'll say x equals 0 and pi here. If I solve the other equation, I'm going to add 3 to both sides, and I'm left with sine squared x equals 3. Now the way to undo a squared would be to take the square root. Remember, when you square root a variable, you get plus or minus. So I have sine x equals plus or minus 3. And if I go to the unit circle now, this never happens. There is no solution where sine is root 3 or negative root 3. So the only two answers to this equation are 0 and pi. As we move on, you'll notice again in the second equation, there are multiple trig functions. In this case, I can't do a lot of factoring right now like I did in the last one. I'm equal to 0, but there's nothing common to factor out. For the next couple examples, we're going to have to start using some of our trig identities. Now, I can rewrite cosine squared with a Pythagorean identity. I can rewrite that in terms of sine. Let's rewrite cosine squared as 1 minus sine squared. That's my Pythagorean identity there. I'll leave the rest the same. We're going to distribute in the 2. And to me, this looks a lot like the previous equations we were solving. If I rewrite the order a little bit, let's go ahead and I'm going to add everything to the other side to make my squared positive. So we're going to get a positive 2 sine squared, a negative 3 sine x, and a negative 2. Again, I moved everything to the other side to make that sine squared positive. Now I can use some u substitution and let u equal the sine x, and I have 2u squared minus 3u minus 2. I'm going to leave this one here. I want you to go through and learn, use what you learned yesterday to finish off this equation. We'll go over this in class the next time I see you. Let's go ahead now and look at another one. Same idea, cosines and sines, nothing in common to factor out. It's already equal to 0, but I see cosine 2x. Now, I have a couple different double angle formulas I can use for cosine. If you remember some of those double angle formulas for cosine of 2 theta, I can have cosine squared minus sine squared. I can use 2 cosine squared minus 1, or 1 minus 2 sine squared. Now, looking at what else I have in my equation, I also have a sine, so I think I'm going to choose the third one. That way, all I have in my trig equation are sines. So I'm going to replace this whole cosine 2x with 1 minus 2 sine squared x. I'm still going to have the plus 3 sine x and the minus 2. Just like I did in the other one, I'm going to add everything to the other side to make my sine squared positive. So we're going to have 2 sine squared, a negative 3 sine x. Now the positive 1 and the negative 2 add up to negative 1, and when I flip it over, it turns positive. So we're going to have plus 1 there. Now we can go ahead and again use some u substitution. Let's let u equal sine x. And just like the previous equation, I want you to go ahead and finish this one out on your own. The last example we're going to look at right now deals with decimals, so we're no longer on our unit circle. This is extremely similar to the ones we solved for our standard. We have tan x equals 12.80444, and we're trying to solve for x. Now, I hope you're thinking right away to use the inverse button on your calculator. Now, make sure your calculator is in radian mode. When you do that, you get x equals 1.4929. The thing we need to think about, though, is if we have all the solutions between 0 and 2 pi. Right now, the 1.4929 is a quadrant 1 answer. If I take pi over 2, that's about 1.7 something. That's why I know 1.49 is in quadrant 1. The other quadrant where tangent equals a positive is down here in quadrant 3. In order to get this same answer, but have it be in quadrant 3, I'm going to take my answer and add pi to it. When I do that, I get 4.6345. And so those are my 2 solutions for x. Let's look at one more of these examples. Very similar to that one. The last one I want to answer is to solve for x, cosine of x equals negative 0.4317. And again, we'll go from 0 to 2 pi for our answers. Now, we're going to start by taking the cosine inverse. When I take the cosine inverse of negative 0.4317 in my calculator, remember your calculator should be in radian mode, I get 2.02. The thing we need to think about is where is that answer located? Now remember, this is pi. This is about 3.14. This is half of pi, about 1.7. And I want to know, 1.57. And I made that same mistake back here. This should be 1.57. I want to know where is 2.02 in relation to those. And you'll notice 2.02 is here in quadrant 2. And that makes sense because cosine is negative in quadrant 2. We need to decide where is the other place where cosine is negative. And I hope you're thinking in quadrant 3. The problem is if that I add pi to 2.02, I'm not going to get a quadrant 3 answer. I need to know my quadrant 1 angle that matches. Let's take pi 3.14 and subtract 2.02. When I do that, I get 1.12. That's my quadrant 1 answer. I can use my quadrant 1 answer now to add it to my to pi, and then I'll get the answer in quadrant 3. So I'm going to take pi plus 1.12, and I get 4.26. Now that's my other answer I need. And again, the reason I had to find the 1.12 is because to get a quadrant 3 angle, you're going to add your quadrant 1 angle to pi. And that's it for today.